Welcome back to Tutor Corner LLC, and in today's video we will be graphing linear functions. Now in the previous video, name determining if it is or it isn't a function, we learned how to tell if something is or is not a function. In this case, we will only be graphing functions, okay? So graphing linear functions. Now, if you would like to reference the last video, please go to my channel, Tutor Corner LLC, and check out the previous videos. So, graphing linear functions. As you can see, I changed the background because it would be more suitable for graphing. Okay, so just a quick review of functions. We know that for a function, we have x as inputs, and we have some sort of black box over here. And then we have y as the output. Okay, and for every x, there is exactly one y value. All right, so let's start here. First, we need to introduce a few other things before we go into graphing. Okay, so the values or x values, also known as inputs, those values are called the domain, and the y values, also known as the outputs of the function, are called the range. Okay, so x values, domain, y values is range. Now, what helps me remember is the x values, what goes in is the domain because it's your territory. And then consequently, I remember the y values as the range. So in the previous video, we covered that a linear function is represented in y equals ax plus b, okay? And we know that x are the inputs, or the x values are the inputs, and the y values are the outputs. We know that, okay? So what we need to do is to first create a table. A table in which we have x values and we have the y values at the bottom. Okay, you can set up the table vertically or horizontally, just as I did over here. Okay, so let's go over to an example just so we can practice what we just learned here. Okay, so example 1. Given a function in which y is equal to x plus 1. So it is given that it is a function, so for every x value, there are y values. So first thing we're gonna do is create a table, okay? The solution. We write down the x values, the y values. Okay, so as far as the number of x values and y values to choose, I normally do the bare minimum, usually 3, but by default for linear functions I do 5, but it's really a matter of preference. You can do as many as you want or as little as you want. Just know that if you do a lot, you have more insight as to what the graph would look like. Okay, but I think for me 5 is enough. And normally I choose a couple negative numbers. 0, I always choose 0, 1 and 2. Okay, those are my go-to numbers. So now here is what we are going to do. X is equal to -2, and we need to solve for y. So we know that x is equal to -2 for this first set over here. Okay, so we're gonna plug in that x equals negative 2 into y. So y equals x, we know, is negative 2 plus 1. So we're just rewriting this equation down here and replacing the x with whatever x we have here. So negative 2. So y is equal to negative 2 plus 1, which is just negative 1. Okay, so we know that when the input is negative 2, the output is negative 1. So we will write that down on the table right there. And we just keep doing this. The second x value is this negative 1 right there, as you can see. This negative 1, right? So we're going to put that over here. X equals negative 1. So we're going to rewrite this equation again over here. Y equals, we know that it's x, however we know that x is equal to negative 1, so we will put negative 1 in for x plus 1. We get y equals negative 1 plus 1, which is equal to 0. So down here we write down that when x is equal to negative 1, y is 0. Okay? And then we keep doing that same practice right there. Next one is x equals 0. So x equals 0. So we will write down this function again over here. Y equals, this time x is 0 plus 1. So y equals 0 plus 1. 0 plus 1 is 1. So 1 goes beneath that 0. Okay, and we'll move on to the next one. When x equals 1, so we know that when x equals 1, we're going to write this function again. Y equals 1 for x plus 1, and we know that that is y equals 1 plus 1. 1 plus 1 we know is equal to 2. So we will write down that number 2 right down below that 1 which we plugged in for x. Okay? Last but not least for our list is when x equals 2. So we will write that over here. X equals 2. So y, we will write this equation down again. Over here, y equals, x is 2. So we replace x with 2 plus 1. We retain that 1. So y equals 2 plus 1, which is equal to 3. Now our table is complete. So if it asks you to write down a table given a certain function such as this, then this would be your answer. The strenuous part there is just plugging in these x values to determine the y values or the corresponding y values as you have seen here. But no matter what, this is the function that we will be using whenever we plug in the x values, because that is the function that was given to us. Okay? So you're more than welcome to pause this video, but I'm gonna move ahead and move on to graphing this function because we are halfway there. Okay, so I'm gonna reiterate the function over here. We're still in example 1, continued, in which y equals x plus 1, right? Okay, so I'm going to write the table x and y, and we know that for x we have got -2, -1, 0, 1, 2, and for y we have -1, 0, 1, 2, and 3. So let's move on to graphing it. Now, remember over here, we're gonna take this over here and kind of examine it a little bit more, okay? So we know that y equals ax plus b, and in this case, there's no number next to x right here. As you can see, there's nothing there in front of x, so we're just gonna put a 1, okay? So in this case, y equals 1x plus b. So if you take a look at it, whatever's next to x is a, so whatever's next to x here is a, so therefore a is equal to 1. Now b over here, ax plus b, 1x plus b, so b is also equal to 1. I should probably change those just to make it easier to see, okay? So we know that so a equals 1. And then for b equals 1, okay? So we will see where this comes in handy for when we graph it. Okay, so let's create a graph here. Okay. Yeah, that should be decent enough. You can draw it as long or as little as you want. You just got to make sure that the points fit in there. Okay. So let's take a look. Let's label this graph. If it's not already labeled, then it's always good to label your graphs so that way we can see the intervals. This is known as the x-axis and this is the y-axis. To the right side is positive 1, 2, 3, 4. To the left side is negative 1, negative 2, negative 3, negative 4, and so on. And going down on the y-axis, this is negative 1, negative 2, negative 3, negative 4. And going up is we have 1, 2, 3, 4, and so on. All right, the importance here, guys, is that b is also known as the y-intercept. That value will always lie somewhere in this area, okay? So the y-intercept is 1, therefore we will find 1 along this interval. This is negative 4, negative 3, negative 3, negative 2, negative 1, so 1 is right here. So we will place a dot right there, okay? For a is also known as, or sometimes called m, as the slope, okay? Or rise over run. In this case, it's a whole number. 1 is just 1 over 1. So if it were 2, then, for instance, if you had a equals 2, it would be 2 over 1. Because sometimes you have fractions and that's when it comes in handy to kind of know what is the rise and what is the run. So in this case, it rises up 1 and it goes to the right 1. So starting from where we place b in the coordinate plane, we will go up 1 and we will go 1 to the right and put our dot right there, okay? And from that dot, we continue on, up 1, 1 to the right, up 1, 1 to the right. As you can see, it's forming that linear pattern. And what's interesting to see here, guys, is that you see how the x value here is 0 and the y value is 1. X value here is, let me just circle it, x value is 0, y is 1. That corresponds to this dot. And then we have this one right here. X value is 1, y value is 2. So x value is 1, y value is 2. Last but not least, at least from this table matching onto the graph, is this one right here. We'll color it yellow. You can see that the x value, or the horizontal number, is 2. And the y value, or vertical number, is 3. You see that? X is 2, y is 3. And this is where it's at. X is 2, y is 3. Therefore, we graphed it correctly. That's why it's nice to kind of see the table right here and kind of just, see and correlate it with the graph. So now we can see that it has this sort of pattern where it goes up as it goes to the right. And if you were to graph the other dots as well, you will see that they land somewhere there and it continues this pattern. And this is a line, so it's unending. And that is the graph for y equals 1x plus 1. Now, if you have any questions on this, or any comments or concerns, or if you'd like more examples, please let me know in the comments section below. I hope you enjoyed this video, and please rewatch it if you would like to understand more. And once again, use the comments section below. Don't forget to like and subscribe to see more free video tutorials on this. Thank you.